Hello, and welcome to section 4.4. We're looking at power functions and equations. The power function part of it is that you have like powers of x, like x to the power 2, x to the power 3, to the power 4, etc. on one side of the equation, and we're looking at solving those equations and what is the weird stuff that happens. So the first thing I want you to read here is that taking roots of both sides of an equation or raising both sides of an equation to a power, it requires some extra care. Let's explore the weird things that can happen that we have to be careful of. So, for example, x squared equals 9. You might want to take a square root of both sides, which is fine. The square root of x squared is the same thing as the square root of 9, so I did the same thing to both sides. The square root of x squared is 1, or sorry, I mean just x to the power 1, and then you get 3 on the other side. But x equals -3 is also a solution, and we already went over this in chapter 3 a lot. So you have to remember that whenever you take square roots of both sides, you include the positive or negative square root, because -3 squared is 9. So you need to make sure you include both of those. So the same thing applies if you're doing it to the power 1/2. So you might say that, wait, if I have x squared and I want to cancel that out, you might say I'm going to do the exponent 1/2 to both sides, and then take 9 and do that to the power 1/2. Because you might be thinking, well, 2 times 1/2, that's what you do when you have a power to a power, right? Is you do 2 times 1/2, which just gives you x to the power 1 equals, and then 9 to the power 1/2 is the square root of 9 is 3. And you get the same problem. You don't have the -3, so you need to, if you're doing in a 1/2 power, you're basically doing a square root. So just like with a square root, you need to include a plus or minus. So that's something to keep in mind if you ever raise both sides of an equation to the power 1/2. Okay, what about this? What if you have x to the power 3? Well, you might be thinking the same idea as I did here. 2 times 1/2 is 1. Well, 3 times 1/3. So if you do this to the power 1/3, and then you do -8 also to the power 1/3, 3 times 1/3 is just 1, so this just gives you x to the power 1. And this is the same thing as the cube root of -8, which is -2. So you get x is -2. But then, what if you're thinking, oh, well, I did both sides to a fractional power. I basically did a root of both sides. Should we include this plus or minus here? Is it really like -2 or -2, which is 2? Well, let's check. That's one of the key ideas of algebra, is that you're going to forget rules a lot of the time. As long as you know how to check your answer, you'll be able to figure out rules in the future. So we're going to do -2 to the power 3. Is that equal to -8? So that's going to be -2 times -2 times -2. That does come out to be -8, because 2 of the negatives cancel out to make a +4. So you end up with +4 times -2. So that works. What about 2? What about, that's like the -2. So that would look like 2 to the power 3. Is that equal to -8? No. no. This comes out to be 8. So that doesn't work. So it turns out if you have an odd number in the denominator here, like 3 instead of 2, it turns out that you do not want to include a plus or minus. So I told you it takes extra care. This is kind of weird and annoying. So the solution is just x equals -2. All right, what if you have x to the 4th equals 50? We can do the same thing, the power 1/4 to both sides. So, computer problems there, okay. So, let's see. The 4 times 1/4 is 1, and you just get x to the 1 equals 50 to the 1/4. That's basically the same thing as the 4th root of 50. You can get this with a calculator by just doing 50 to the power 1/4, like so. And yeah, it's about 2.659. Okay, so what about here? Should we be including the plus or minus? What is x equal to -2.659 also a solution? Let's check. If you do -2.659 to the power 4, is that equal to 50? Well, if you have 4 copies of this, remember 4 is an even number here, so you're going to have -2.659 times -2.659 times -2.659 4 times. I shouldn't have written so many decimals. I'm going to run out of room. Yeah, 4 copies of this are going to cancel out because they're going to cancel out in pairs to become positive, and you're going to get positive 50. So, yeah, that is a solution. So, so we do need to include the plus or minus here. I guess I should say approximately equal because I had to round that off a bit. Okay, so the moral of the story is this rule here. When you're taking square roots of both sides of an equation, always include plus or minus on one side. Just like we had to do with the a here. This also applies to any even root, like a 4th root or a 6th root. So 4 is an even number, 6 is an even number. So doing the 1/4 power here, you need to include the plus or minus. Okay, so that is a tricky thing to keep in mind, but as long as you're checking your answers, trying to remember that maybe you have a -1, you'll be able to figure out again if you need to. Okay, so let's look at example 2. A $50,000 certificate of deposit at an annual interest rate of R yields 5,000 times 1 plus R to the power 10 after 10 years. What does this equation, 5,000 times 1 plus R to the power 10 equal 10,000, represent? And how many solutions are there, and do they all make sense in practical terms? So let's see. What we're saying here is we're saying this is how much is yielded, like how much the balance in this certificate of deposit account is, how much money there is in the account, at an interest rate of R. And if we're saying that is equal to 10,000, we're saying there's $10,000 in the account after 10 years. So that's what this represents in practical terms. At an interest rate of R. And then we want to see how many solutions are there and do they all make sense in practical terms. So a solution of this is is a value of R, because the variable here is R, and a solution always means a solution of an equation means to find the value of the variable that makes this equation true. So what is the interest rate that makes it so there's $10,000 in the certificate of deposit account? So we're going to try to solve this to see how many solutions there are. So what I would do is divide both sides by 5,000 first. And that's going to give you 2. Okay, and then you want to cancel out that 10th power. You could do a 10th root, which is the same thing as raising it to the power 1 over 10. I'm just going to write it as a 10th root here. And wait, is 10 an even number? Yes, it is. Yes, you're right. Okay, so if that's an even number, we're doing an even root, we're going to include plus or minus here on that side. And so this is going to cancel out with the 10th power. We just end up with 1 plus R equals, well, let's actually do this on a calculator. Remember, the 10th root is the same thing as plus or minus 2 to the power 1 over 10, which lets you do it on a calculator, is 1.072. Sounds like enough decimal places. Okay, and if we're going to subtract 1 from both sides of this, remember the subtraction is going to work differently depending on whether you have a positive or negative number here. So I'm going to write it as equals positive that, and also write another equation where you have the negative version of that. Okay, so when you subtract 1, you're going to get R equals 0.072. And over here, if you subtract 1, you're going to get R equals negative 2.072. Okay, so remember R is an interest rate. So as a percentage, this would be R is 7.2%. Moving the decimal place over 2 spots to make it a percentage. And 7.2% kind of makes sense as an interest rate that exists. But what happens with the other one is if I move this decimal place over, I get R is negative 207.2%. That doesn't make any sense. So what's happening is that if R is this negative 2 point something, and you plug it into this, you're going to get 1 minus 2 point something. You're going to get a negative number to the 10th power. And it works out to be the same as the 1.072 to the 10th power. So it is a solution of the equation. So this equation has 2 solutions with this even power here, but only one of them makes sense in practical terms. So the actual interest rate is 7.2%. Okay, so that's that one. So sometimes in real life situations, even though negative 2.072 is a solution of the equation, you don't always want to include the one that comes from the negative part, because it doesn't always make sense. Okay, let's do another example of solving equations. We've got the square root of t plus 9 equals 21. And if you subtract 9 from that, from both sides of this, to just get the square root of t by itself, we've got the square root of t equals 12. Okay, and I just want to notice that equation B here is almost the same. It just has the 21 and the 9 switched. So if I was going to get the square root of t by itself on this side, you're going to get the square root of t is negative 12. Okay, so let's see. If you wanted to solve this, like what we want to know, what is t, so that when you take the square root you get 12, you can square both sides. And you'll get t is 12 squared, which is 144. And let's check that. Yeah, this works. So the square root of 144 is 12. That sounds good. So that's the solution. But then over here, the equation is the same, except you end up with the square root of t equals negative 12. We're going to square both sides, doing the same thing to both sides of the equation. And you get t equals, well, negative 12 times negative 12 is positive 144. And if you were to check this, well, it's the same solution as what we got here. So the checking would go exactly, oh, sorry, the checking wouldn't go the same way because it's a different equation, excuse me. So if we're going to check it, brain fart there, we're going to do the square root of 144 plus 21 and see, is that equal to 9? Well, the square root of 144 is 12 plus 21. Is that equal to 9? No, it is not. So, so squaring both sides here I didn't make any actual mistakes, but squaring both sides gave me something that's not really a solution. This is what we call an extraneous solution. It's like a solution that came along for the ride somehow. It showed up here looking like a solution, but it's not really a solution. So the actual equation has no solution, because whenever you take a square root of anything, it's always positive. So it can't be negative 12. So yeah, so this equation has no solution. And if you don't believe me that the square root of anything is always positive, let's just take a calculator and see what happens. If I do the square root of 144, is it going to give me plus or minus 12? No, it's just 12. Or if you do the square root of negative 144, it gives you a non-real answer, meaning like it's not a real number. It doesn't really exist. We call it an imaginary number, but we're not going there in this class. We're saying that this doesn't exist. So square roots are always positive, except if you do the square root of 0. Whoops. The square root of 0. It's just 0. So square roots are always 0, or the result is positive, but it can never be equal to negative 12. Okay, so that's what this rule says. When squaring both sides of an equation or raising both sides to any even power, like 2 is an even power, so is 4 or 6, etc., always check your answer because this operation may introduce extraneous solutions. All right, so always check your answer. I mean, always, because I say you should always check your answer anyways, because it's a good habit. You'll learn more math doing it. You'll get practice with arithmetic. You'll find mistakes, which is good. And you'll get a better understanding of why your solution method works the more often you check your answer. But here you really have to do it because you might make no mistakes. You might do everything just right and make no mistakes going through it and still get a solution which is not really a solution. So to avoid that, you got to check your answer. All right, here's next up is some exercises for you to do. I'll show you the solutions if you need them in the next video.